Hi, and welcome back to the shop. Today we're going to carry on with our part 7 of our series of videos that's all about jigs and fixtures. And in this part 7, well, we're going to be looking at turning or producing our drill bushings. We need 2 of them. And well, pressing them in place into the tool body. And then using this jig, I'm going to drill 2 holes in each of my 8 parts. Then we can do some quality control and see what we ended up with as far as precision goes. But before we can start to look at how we're going to produce those drill bushings, we're going to have to determine what the OD, or the outside diameter of those bushings, is going to be, because I want a press fit between the bushings and the body of the tool here. This is a relatively small diameter part, 1/2 inch, so certainly 1/2 thousandths of an inch per side, or 1/1000th of an inch interference total, will be more than good enough. But those holes that I produced, are they really a 1/2 inch within a 10,000ths? No, I'm sure they're not. We're going to have to measure them. And I'm not going to measure them with a direct measuring tool, something that has a readable scale on it. I'm going to do a comparative measurement. One, it's a good way to get something quite accurate as far as results go. And, well, it's something that we don't get to see all that often. So let's take a look. And for that, I'm going to need, well, some shim stock. I have 3 different sizes or thicknesses of shim stock here. A 2/1000ths of an inch, 1.5 thousandths, and 1/1000th of an inch. And using a regular pair of scissors, I've cut 3 strips from these sheets. So 1 thou, 1.5 thou, and 2/1000ths of an inch. I'm also going to need a very accurate pin of some sort. Now this is a hardened and ground dowel pin that I have measured very accurately to see that it is a 1/2 inch plus or minus 1/10,000ths. So it is quite accurate. And well, obviously I need the part that I want to verify. So let's take a look at that. Here's our pin, and we can see that it fits readily in the hole here. I wouldn't exactly call it loose, but it is not tight. There is a little bit of play here, and I'm guessing that there is at least 1/1000th of an inch of play, maybe a tad more. Well, we'll have to see. Well, how much? Well, we're going to do like Goldilocks and the 3 bears here. We're going to have what we think is not enough, what should be just tight enough, and what should be our good press fit. So our 1/1000th of an inch shim here shouldn't stop that from going in. But I see it has taken care of all the looseness that there was in that fit. So that is not enough for a press fit. If I look here, my 1.5 thousandths of an inch shim, that is going in. It's slightly tight, a light press fit, but that won't be enough for what I want to do here. I'm going to want a good press fit, about 1/1000th of an inch on a diameter like this 1/2 inch diameter pin. So let's put that in there. There we go. That'll be just perfect. Now, I know that the 1 thou was just taking care of all the looseness. So I'm going to have something about 1/1000th of an inch interference, 1 thou, 2 thou. So that's 1 thou difference, or if we prefer, a 1/2 inch interference per side. And this will do quite nicely. Now, that means that what I want as far as the fit goes, a good press fit, well, I have to have 2/1000ths of an inch over my 1/2 inch dowel. That is very accurately a 1/2 inch, or if I prefer, 502/1000ths of an inch. And that's the diameter that I want to produce my drill bushings at. Okay, well, my lathe is ready to go. And what do I want to do? Well, I want to produce my 2 drill bushings. And I'm going to do that starting with this bar of hot rolled tool steel. And how am I going to go about it? Well, this lathe isn't the most accurate machine. It's a home shop. I don't expect it to be that accurate, but I have to work around that problem because I do want these bushings to be quite accurate, especially as far as the press fit goes and the concentricity of the hole in relation to that outside diameter. So how am I going to do that? Well, I'm going to start by holding the part in a 3-jaw chuck with about 1.5 inches sticking out. I'm going to surface the end of the part. I'm going to spot the location of the hole with a center drill, but just the very tip. I want something rigid that's just going to make an indentation to guide my next drill up into the right position. So I'm going to spot, then I'm going to drill slightly smaller than a 1/4 inch because I want a 1/4 inch hole here, and I'm going to finish by reaming the 1/4 inch hole. Now, this isn't the most accurate machine. I've said that. And what I'm going to do? Well, first thing, before I move anything, I'm going to set up a dial indicator. And if I got lucky, and really just if I got lucky, that hole might be quite concentric. If it was within 1/1000th of an inch, I'd be happy. But to be honest, I really don't expect that to happen. If that's the case and it's not accurate, well, if it is accurate, well, then it's pretty simple. I turn the outside diameter to the diameter that I want. I cut off my first piece. I resurface, cut off my second piece, and then I can resurface the second sides of both bushings if I want to. Well, I'm going to want to, just to get it nice and perpendicular to the axis of the bushing. And that's if the hole is in the right place, but it probably won't be. So what am I going to do? Well, let's say I indicate the hole, I realize, oh, it's not in the right place. I'm going to turn the outside diameter as long as possible, so I'm guessing about 1.5 inches. Then I'm going to cut off that end that I've just turned. I'm going to set up a 4-jaw chuck and chuck this part in that 4-jaw chuck. Now I'm going to be holding it parallel, but not necessarily concentric. Why parallel? Because I turned the outside diameter before I removed it from the 3-jaw chuck. So the outside diameter is going to be a concentric, but that center diameter won't be because it was 2 thou off. It's still going to be 2 thou off or 1 thou off or whatever. So once I've done that, I've set up back in the 4-jaw chuck. I'm going to center the part, but not on the outside diameter, but on the hole. So I'm going to use the hole to center, get the hole as close to concentric as possible. And once that's the case, then I can come back to my outside diameter, my OD, and turn it down to the diameter that I wanted. And just by memory, I think it was 0.502 or 502 thousandths of an inch. And once that's done, well, I can cut off my 2 ends, surface the second side of both ends, and then I can heat treat, polish, and I'm ready to press fit. So let's take a look at that. And well, as I mentioned earlier, we're going to want to indicate the hole, and we can see there that we're a little over 1.5 thou, and that's, well, it's not good enough. And well, before I do anything, since I'm moving over to a 4-jaw chuck, I'm going to want to turn the outside diameter of the part to ensure that it is parallel to the axis of the hole. I didn't say concentric, I said parallel. So all I want to do is turn the OD slightly enough to clean it up and bring it parallel to the hole. If we want to know where to go, we have to know where to start. So I can see here, there, I'm measuring just under, well actually right on 112 thousandths of an inch over 1/2 inch. I want to leave 2 thou on the part for my press fit. So that means that I'm really looking at 110 thousandths of an inch coming off this part. Now my lathe here cuts on the radius, so that means that I'm going to have to take off about 50 thou before I start to get serious with the measuring. Right on the 512 that I was expecting. So what do I have to do now? I want to leave 2 thousandths over 1/2 inch. So I want 502. And that means I have 10 thousandths of an inch to come off here to be at my final diameter. So there, maybe 1 or 2 10,000ths under 502 thou. So that'll do just fine. So my part hasn't moved. I've left it in there. I've put a little glue on it because I'm going to want to scribe some lines and I want them to be more visible. But if I take the part out of there, I could lose my concentricity, which wouldn't be the end of the world, but I could get a little thrust going, or end thrust, and that is a problem. Now, normally what I do now is, without removing the part from the machine, I get a part off tool set up, and I just part off my two parts, my two drill bushings. But just because I'm a bugger for punishment, we're not going to do it that way. Well, many of you don't have parting tools, so we can do it with a good old-fashioned hacksaw and some elbow juice. Now, that is a problem, however, because I'm going to lay out a line and I'm going to saw off the first part. Now, that first part that I'm going to saw off is going to have a good end and a bad end. Having a good end is fine because it helps me with measuring for my second surfacing operation, because if I cut them off with the hacksaw, I'm going to have to surface that second end. But my tool is already set up, so what I'm going to do to just make my life simpler is I'm going to saw the first part off without moving anything. I'm going to use my surfacing tool to surface the new end to get it nice and perpendicular. Then I'll lay out and saw the second part off, and that way both parts will have a good reference end. So let's take a look at that. Now, you may be wondering, how am I going to line this up in my 3-jaw chuck so that I get it good and parallel to the axis of rotation? Because I want my two ends to be parallel. And here's what I'm going to use. I've mounted a 1/4-inch pin in the tailstock, well, in the drill chuck in the tailstock, and I'm going to use that to insert the part into my 3-jaw chuck. So my parts are ready for heat treatment. I want them hardened, well, because I want to reduce wear. These are press fit bushings, so these are the bushings that are going to be there till the end of this run. Now we're just producing 8 parts, but we're going to pretend like we're producing many, so I'm going to harden them for the wear problem. And these are quite small parts and they're tool steel, so they're easy to harden. And well, to do that, I don't need an elaborate setup. All I need is a propane torch and some quenching oil. Now, important, this is quenching oil. It's not just any type of oil. And that means that its flash point is higher than the temperature at which it burns. And that means that if it does catch on fire, it'll extinguish itself as soon as I remove the energy source that's keeping it lit up. And that energy source, well, is my part. So I'm going to heat these up to a little more orange than cherry red. And once I'm there, I'm going to rapidly dunk them. I'm not going to touch the oil, I'm not going to touch it and pull it out. That's the energy source that this oil needs to catch on fire. It also needs oxygen. So if I dunk that into the liquid and move it around without taking it out, this cannot catch on fire. If I do pull it out and it does catch on fire because I haven't left it in long enough for the parts to go down below 700 degrees, let's say, well, all I have to do is drop the part in there and it'll again extinguish itself because the heat source won't be there anymore. It'll be in the bottom of it. So that's what I want to do. Now, usually we say hardened and tempered. Now, these parts don't have inside angles on them. They're quite standard, very easy to heat treat and very hard to crack. So I'm going to heat treat them, I'm going to harden them, but I'm not going to temper them. If I was going to temper them, well, once they were hardened, I'd go back on the lathe and mount them and polish just a part of them so I could see the shiny silver color. Then I'd come back with the propane torch and just heat them up enough to get a nice dark blue color on them, and that would be the tempering. But I'm not going to do that here. So let's take a look at the hardening process. Oh, I would normally have a larger quantity, but these are very small parts, so don't need to have that much oil here. And well, I wouldn't normally use something as flimsy as this, but I wanted something transparent for the effect that it'll do. We can see it happen as we dunk it in there. Should be pretty cool. Let's take a look at it. So the parts are nice and cool. I can pull them out of there and, well, clean them up a little bit. Don't need to polish them to death here. Just get most of that oil off. Now, I'm going to want these bushings to be press fit in this body. But I'm going to want the ends of the bushings to be flush with the bottom of our pocket here. And well, just to not give ourselves a headache, because my bushings are a little longer than the thickness of the part, I'm going to insert one of the parts in there, and that will give something to lean up against when I'm pressing them in, and I'll be sure that they're at the right depth. The only other thing that I have to do here, other than press them in, is before that, I'm going to want to check and polish the central bore on these things, just to make certain that my 1/4-inch drill actually fits in the hole. So let's take a look at that. So I have my 1/4-inch drill mounted in my drill chuck. My drill press is all set up, and I have this vise on the table. And you're wondering, why the vise? Well, I don't know if you recall, I don't, but I know that somewhere back then, maybe in part 2, 3, or something like that, I mentioned that our part had quite a small surface, and that really wasn't the best thing for a plate jig like this. It's not stable, and when I drill through here, and these are through holes, well, they could very well snag, and I'm not holding this by very much. I'm not that courageous. So what I'm going to do, and that is why I've chosen such small-headed screws and not actual large thumb screws, is that I'm going to hold the jig in the vise on the little parallel notches in the jaws here, and that'll stabilize everything. So now I want to measure, and what's important here is the center to center distance between the two holes. Not the hole diameters, they weren't that important. So I really want the center to center distance, and that can cause me a problem. Now, both of these holes should be pretty close to being identical. I used the same tools at the same speeds with the same bushings, so they should be, as far as diameter goes, pretty close one to the other. But what isn't important is their diameter. So I don't even know if they are a 1/4 inch. I know they're at least a 1/4 inch because the drill was a 1/4 inch. But I don't know how much oversized that they actually are. And it doesn't really matter here. What I want to know, because what was accurate on the print, was the center to center distance. Now, if I were to measure from that inside of the first hole to that inside of the second hole, well, the math would tell me that that should measure 1/4 inch. But that takes into account the diameter of the holes, and that's not what I want to know. To get the center to center distance, I got to eliminate that variable, the diameters. And that's what I'm doing here. So I'm using the mill to measure. I've set up a dial indicator, and in the first hole, I've set my dial to 0, and I've set my graduated scale to 0. I'm being very careful with backlash. Also, I've approached this edge in the same direction that I'm going to approach this second edge, so that there is no backlash in play here. So I'm there, I'm going to pull out, I'm going to move with my graduated collar a 1/2 inch or 500 thou, and then I'm going to come back down with my z-axis and see where I am, because whatever I see on the dial here should be pretty close to how much I'm going to be out. Now I'm looking here between 1 thou and 2 thou. If we get less than 1 thou, well, we really just got lucky. So let's take a look at that. So there, just under 1/1000th of an inch. We got lucky. I mean, that's great for the tools that we have here. Now, this concludes this portion of the project. We have our 2 holes through our primary surface. But we're not done the part, because we have a hole to produce through the tertiary surfaces and then an angle to cut on one of the corners. So that means we're going to have a jig and a fixture. And the jig, well, is going to be what I call a modified angle plate jig, and we're going to combine an angle plate jig with a vise fixture. It'll make things a lot simpler. And then, well, we'll produce a very basic vise jaw fixture for milling that 45-degree angle on the last corner. So that'll be in, I guess, at least 2 more videos. So until we meet again, well, have fun, be safe, and happy machining.